Hello dear students. So we are into our last session of basic mathematics course. Today we are going to finish the vectors chapters. We are going to discuss the dot product and the cross product. That means the product of vectors. So let's begin everyone. Before we start, I would like to remind you that you guys need to subscribe our channel. If you haven't done that, please do so very quickly, and also ask your friends who are into Olympiads to join this channel. We are currently covering the vectors chapter and we have done this part. Today we are going to cover the dot product and the cross product. Let's start, guys. So we are now going to talk about product of two vectors. Okay. So guys, when we try to multiply two numbers, let's say 5 and 4, we get the outcome as 20. Okay. But when it comes to vectors, okay, there are two types of products that we have defined. Okay. Like let's say there is a vector A, okay, and there is a vector B. Okay, now if we want to multiply these two vectors, then there are two types of products that have been defined. One type of product will give us a scalar output, okay, and therefore it is called scalar product of the two vectors. The other kind of product will give us a vector output, and therefore it is called a vector product. Okay, so we have to study about both kinds of products. Both kind of product find their application in various concepts of physics. We are right now understanding the mathematical aspect of it. I will also touch upon the some of the applications of these both kind of products. Okay, so let's start. So we'll start with the scalar product. All right, so remember, scalar product will give us a scalar output. Okay, so scalar product is represented. First of all, let's talk about how we represent it. It's represented by a dot. Okay, it's represented by a dot. Okay, and therefore it is also called as dot product. Okay, therefore it is also called as dot product of two vectors. Okay, it is also called as dot product of two vectors. Now let's say we have, what is the definition? Okay, what is the definition? Like how do we define the dot product? So let's say there is a vector A, okay, and let's say there is a vector B. Okay, of course we can find out the angle between the two vectors. We know how to do it. We have to first make the vectors either co-initial or co-terminus, and then we have to pay attention to the smaller angle in that figure. That will become the angle between the vectors. So if I talk about A dot B, okay, A dot B is defined as A B cos theta. That is magnitude of vector A into magnitude of vector B into cos of angle between them. Now remember guys, this is definition. This is definition. That means that we don't have any explanation for this. We have declared that whenever we will have to calculate dot product of two vectors, this is what we are going to do. This is what we are going to do. We are going to multiply the magnitude of one with the magnitude of the other, and we are going to multiply with cos theta, where theta is the angle between the vectors, and that will give us the result. Okay, so this is the definition. But by using this definition, there are a lot of conclusions that we can draw. Let's start looking at those conclusions. So we are now going to talk about properties of dot product. Okay, and everything that I am going to state now, everything that I'm going to tell you now will be based only on the definition, like it will be derived from the definition. So the first property that you have to keep in mind, notice that A dot B was defined as AB cos theta. Now A and B are scalar numbers. When we are multiplying scalar number, even if we interchange the order, like 4 into 5 and 5 into 4, they both give us the same result. So we can write it as BA cos theta also, which would now mean B dot A. So we know that the scalar product is commutative. It's commutative. That means you can interchange the place of A and B, and yet the result will remain same. So that is one thing that you have to keep in mind, everyone. Okay, so that is one thing that you have to keep in mind. Next thing, okay, next we can talk about, let's say, what if I take dot product of a vector with itself? Okay, if I do that, based on the definition, I should be writing A into cos of 0, because what is the angle that a vector makes with itself? That's 0 degree. So cos 0 is 1, so it should be A square. So A dot A would be A square. Okay, A dot A would be A square. Okay, and then notice that by using second property, if I talk about I dot I would mean magnitude of I cap into square. So magnitude of I, it's actually 1 cos 0, that means 1. Similarly, j dot j will be 1, and k dot k, sorry, yeah, k dot k will also be 1. So remember this, I dot I, j dot j, k dot k, all this is 1. Okay. Next, we can talk about that what if A vector and B vector are perpendicular to each other. Okay, if they are perpendicular to each other, then A dot B will mean A B cos 90, that means it would be 0. So this is a very important property because it is used as a test of perpendicularity. Okay, if we have to whenever we have been we are asked to check whether two vectors are perpendicular or not, what we do, we take their dot product and we check the value of the dot product. If we end up with a 0, then we declare that the vectors are perpendicular to each other. But if we don't get a 0 value, if we get anything else, then we know that the vectors are not perpendicular to each other. So this is used as test of perpendicularity. Please remember this. It is going to be useful in many questions. So this is used as test of perpendicularity. Okay, so this is a very important property. And using this property, we can frame further rules for ourselves. Suppose I want to take I dot j. Now remember, I dot j would be same as j dot I because of the commutative property. But I and j, they are perpendicular to each other, and therefore I dot j would give me a 0. Similarly, j dot k, they are also perpendicular to each other. Okay, so j dot k would also give me a 0, and I dot k and k dot I will also give me a 0. So what I've done here, notice that we have 3 unit vectors I, j, k, and with 3 unit vectors I can make 3 pairs ij, jk, ki. So I've checked all the pairs. For every pair it's 0. I dot I, j dot j, k dot k was 1, but if you multiply I with j or k, you get a 0. Okay, and that's a dot product. Okay, so this we have seen. Next, we can talk about next property. So suppose a vector A is written as ax I cap plus ay j cap plus az k cap, and another vector B is written as bx I cap plus by j cap plus bz k cap. So vector A is written in terms of ijk, vector B is written in terms of ijk, and now let us say we have been asked to multiply A dot B. Okay, so let's see what we will be doing. Okay, so we will write ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap, and then should I write a cos theta here? What do you think, guys? I have written A vector dot B vector. Should I write a cos theta here? Those of you who are thinking that yes, a cos theta should come here because we have written A and B, notice that I have not written magnitude of A or magnitude of B. I have not written that. I have just substituted vector A in another form. This is still a vector. This is not magnitude. So no cos theta will come here. I will tell you when cos theta would have come there. Instead of this, had I written ax square plus ay square plus az square, now that's magnitude of A. This is vector A. So here I have just substituted vector A in another form. It is still vector only. It is not the magnitude of A. This is magnitude of A. Similarly, if I write root of bx square plus by square plus bz square, that's magnitude of B, and now cos theta would appear. So A dot B can be written like this, or it can be written like this. We'll continue with this. We'll see what we get when we expand this. So I have one bracket containing 3 quantities. I have another bracket containing 3 quantities. I have to multiply this. So when we expand such thing, in algebra, when you do this, okay, for example, if I ask you to expand A plus B plus C with X plus Y plus Z, when you expand the bracket, how many terms do you get? And how do you expand this? You do this, A into X, you write AX plus AY plus AZ, then BX plus BY, and so on. Okay, so similar way we are going to do the expansion. Similar way we are going to do the expansion, okay, and we'll see what we end up with. So this part I'm leaving here, I'm going to use it later on. This part I'm continuing with the calculation, I'm expanding this, okay. So let me do the expansion, okay. So we will get AX BX into I cap dot I cap. Notice, I'll go back. So the first term here is AX I cap, BX I cap, and therefore when we multiply these two, we will get AX into BX I dot I. Okay. Similarly, our next term would be AX BY I dot J. Please confirm this. AX I cap into BY J cap. Okay. So AX BY I dot J. Next term would be AX BZ I dot K. Okay, again confirm AX I cap into BZ K cap. Okay, then what next? We will write AY BX J dot I. Okay, let's go back. This AY BX. Okay, AY into BX. Next term would be, I want you to expand this on your own, guys. Don't do what I am doing. Do it on your own and then match whether you are getting the same result or not. Okay, I am now doing it quickly. Okay, so this would be J dot K. Okay, and then finally we will have AZ BX K dot I, and then AZ BY K dot J, and then AZ BZ K dot K. So we got our 9 terms. Okay, we got our 9 terms. And notice, out of these 9 terms, 6 are 0. Notice wherever we are getting I dot J, I dot K, all these terms are 0. So these 2 are 0, J dot I is 0, J dot K is 0, K dot I is 0, K dot J is 0. So we are left with 3 terms only. I dot I is 1, J dot J is 1, K dot K is 1. So ultimately what we are left with is AX BX plus AY BY plus AZ BZ. So this is how you can calculate dot product of two vectors when the vectors are given in IJK format. Okay, when the vectors are given in IJK format, this is how you can do this. Okay, let me take some examples now. Whatever we have studied till now, let me cover some examples. Okay, so let's say a vector of 10 magnitude was given like this. Let's say a force of 10 Newton, and this is another vector. Let's say this is force vector, this is displacement vector, which is, let's say, 20 meter, and let's say they have an angle of 60 degree between them. So if I ask you to calculate F dot S, alright, so right now let's notice how the information has been given to us. We have been given the magnitude of the two vectors, we have been given the angle between the two vectors, so we are readily capable of calculating the dot product. It would be 10 into, okay, here you write into, it doesn't matter. Okay, when you are multiplying the scalar numbers, remember 10 and 20 are scalar numbers. When you are multiplying them, you can use whatever representation you want. Okay, so 10 into 20 into cos 60. Cos 60 is 0.5. So this will become 100. Newton into meter. Actually, Newton into meter is called joule, but I will leave it here like this. So when the vectors are given like this, the magnitude is known, the angle is known, this is how we can calculate the dot product. Let's say if instead of like this, we were given vectors such as this, like let's say the force was given as 2I cap. I'm not writing the same force, maybe a different force. 2I cap plus 3J cap plus 4K cap, and the displacement was written as minus 3I cap plus 3J cap plus 7K cap. And then suppose we were asked to find out F dot S. Okay, now what we were supposed to do? Now we were supposed to use the formula like F dot S. We know that if the vectors are given in terms of IJK, then how do we get the dot product? We multiply x with x component. So 2 into minus 3 plus 3 into 3. Notice that you don't have to write IJK here. The outcome is a scalar number, so here no IJK would be present. 3 into 3 plus 4 into 7. So the outcome would be minus 6 plus 9 plus 28, and that would be how much? 36 minus 6, 30. Okay, so 30 Newton meter would be the outcome. So please notice that we have considered both the situations. In one situation, the vector was given with magnitude and the angle between the vector was depicted to us. In the other case, no figure was given. Both the vectors were given in terms of IJK, and then we were supposed to find out the dot product. So in that case, this is what we are supposed to do. Let us consider one more example, rather several more examples. So let us say a vector A is I cap plus 2j cap minus 3k cap. I'm writing randomly. Vector B, okay, let's say vector B is 3I cap plus let's say some unknown alpha j cap plus 4k cap. And we have been told that A vector is perpendicular to V vector, and using this we have to find alpha. Okay, we have to find the value of alpha. See how we are going to do this. We are going to say that, okay, if A vector is perpendicular to B vector, then it means that A dot B should be 0. Okay, A dot B, that should be 0. And how much is A dot B? It is 1 into 3, 3, plus 2 into alpha, that's 2 alpha, then minus 3 into 4, that's minus 12, equal to 0. And from here we can say that 2 alpha is equals to 12 minus 3, that is 9, and alpha is equals to 4.5. So you can see that how we are going to use the condition. All right, now application of scalar product in physics. Application of scalar product. Let's do one thing. Let's talk about application a little bit later on. I first want to talk about a few more things. So in this example, you have done this. Now suppose I want you to calculate the angle. Okay, let's say this was part 1. Okay, part B, I want you to find angle between A and B. Okay, I am asking you to find, actually that is given to us, no, that they are perpendicular. So we need to change the question now. Okay, let's do a new question then. I'm going back. Okay, let's do a new question. So suppose we have been given a vector which is 2I cap plus 4j cap minus 6k cap. I'm writing random numbers, guys. Okay, no particular trend or nothing. Okay, minus j cap minus let's make it positive. Okay, I want to know angle between A and B. Okay, I don't know the angle here. How much is the angle? So see what we are going to do. So A dot B is something that we can calculate. Okay, and we know that A into B is A dot B is AB cos theta. In other words, if we get the value of cos theta, we are done. So A cos theta would be A dot B divided by magnitude of A. Notice that you can calculate A dot B. A dot B would be 2 into minus 3 plus 4 into minus 1 plus minus 6 into 3 divided by magnitude of A. Now magnitude of A would be root of 2 square plus 4 square plus minus 6 square, although minus will not matter. And then magnitude of B. How much is magnitude of B? This is minus 3 square plus minus 1 square plus 3 square. Okay, so let's finish the calculation. So this is minus 6 minus 4 minus 10, minus 6 minus 4, and then minus 18. So minus 28 divided by root of 16 plus 4 is 20, and 20 plus 36 is 46. 36 plus 20 is 56 actually. And this is 9 plus 1, 10 plus 9 again, 19. Okay, so since we have got the value of cos theta, it means that we are now aware of theta. So you can see that how we can use dot product to get the angle between the two vectors also. All right, so there's one more thing that you can learn. Now whatever I'm telling, you can choose to ignore this portion, guys. Suppose we have been given a vector A. Okay, what I'm teaching right now is component of a vector along another vector. You can choose to ignore this part. This is something that if you understand, well and good. If you don't understand, forget this. So let's say this is a vector A, and let's say this is another vector B. It is not necessary that the given vector B would be co-initial to A, but we can make it by using invariance. We have learned that. So let me draw the figure directly as co-initial. Now I'm talking about, let's say, component of A vector along B vector. So first of all, these words, what do they mean to you? Like component of A along B. It would mean that if we resolve vector A, I hope you remember resolution. If we resolve vector A into two parts such that one of them, okay, such that one of them is along B vector, then those parts would be like this, okay, and the other would be this, okay. So this is component of A along B, and how do we get it? So if this angle is theta, we know that this would be A cos theta. We know this, okay. So we are trying to get A cos theta. This would be the component of A along B, and we know that A cos theta can be written as A cos theta into B divided by magnitude of B, that is, and this is what? This is nothing but A dot B divided by magnitude of B. So this is how you can get component of a vector along another vector, okay. So you can remember this, it's a good thing. So if two vectors are given to you, you want to know how much component one vector has along the other vector, this is how you get it, okay. So that's all about scalar product. I can talk about applications now, okay. So the most common application that you will come across, okay, is work done, okay, work done by a force, okay, work done by a force. This is something that you will see soon. So if there is a block and some force F was acting on it, and because of this a displacement S happened in the block, okay, then work done by force is defined as F dot S. This is how we define work. Of course, we will study about work in greater detail in the work energy power chapter. This is just, you can say, the surface that I am showing you. There are a lot of things to be understood regarding work, but right now you can just remember that one of the major applications of dot product is to calculate work done by a force. There are many other applications, but right now we can be satisfied with this one. Okay, next we'll move to vector product. Okay, so I told you that there are two ways to multiply vectors. One gives you a scalar outcome, we call it a scalar product, and the other gives you a vector output, we call it as vector product. Okay, so vector product is represented by a cross. Okay, it is represented by a cross, okay, and therefore it is also called cross product, okay. Now those of you who are thinking, sir, we have studied in mathematics that 5 into 4 is 20 and 5.4, like not decimal, but 5 multiplied by 4 is also 20. So yeah, but that is scalar numbers. These are scalar numbers. With scalar numbers, it doesn't matter, but with vectors, the sign matters, So again, we will proceed in the same manner as how we did for the dot product. We will start with the definition. Okay, we will start with the definition. So how is the cross product defined? So A cross B is defined as, watch carefully, magnitude of A into magnitude of B into sine theta. Now till now whatever I have written, it's all scalar quantities. So as of now the outcome is not a vector yet. Now we put a n cap here. So n cap is a unit vector in an appropriate direction. Now what is that appropriate direction is something that we need to learn, okay, but all these are scalar numbers, and when we put this unit vector, that is when this outcome becomes a vector. So this is the definition. I want you guys to remember this, and as I said before, because it's a definition, there is no explanation to it. This is how we have defined the cross product, and everything regarding cross product will be derived from this definition. The first thing that we need to do is to understand that what is this appropriate direction in which n is pointing to. So to learn that, this is a little bit complicated, please bear with me. So let's say there is one vector A and let's say there is another vector B. Okay, so first of all, make them co-initial. Even if they are not, make them co-initial. Once you do that, you will be able to identify the angle between them. Now what you have to do, you have to use your right hand, please. Okay, so use your right hand. Keep your thumb perpendicular to your fingers. Can you see that in my diagram, in whatever I've done? Like my thumb is perpendicular to my fingers. Okay, then you have to place your fingers along the vector written first. Okay, in this expression, whichever vector is written first, you place your fingers along that. Okay, and what you have to, so I can place my fingers along A like this. I can place my fingers along A like this also. So I can do like this and I can do like this. In both the situation, my fingers are parallel to A. Okay, but between these two options, one is wrong and the other is correct. I have to place my hand in such a manner so that I am able to turn my finger towards B. Okay, not like this, not the opposite way. I have to turn my hand along towards the direction of my upward palm, and that should be that I should be able to turn it towards B. So I'm pointing towards A and now I'm turning towards B. While doing that, whichever direction your thumb is pointing, that is the direction of N cap. So right now in this diagram, N cap is into the board. Into the board is indicated as a cross. So right now N cap is into the board. Okay, A dot B, it's into the board. All right, I hope you will remember. So that is the same has been depicted here. You place your hands along a vector A and then you turn it towards B. Okay, through the angle between the vector. You can say, sir, I can turn towards B like this also, like, going from the longer route. No, you don't have to go from the longer route. You have to go through the angle between the vector. The angle between the vector is always the smaller one. Okay, so this would give you the vector of the N cap. Okay, so that is the definition. So using this definition, again, we can write a lot of properties. So let's start. Okay, so first property, A cross B and B cross A, are they equal? Let's check. So in the same diagram, if I talk about B cross A, I will extend my right hand, I will keep my thumbs perpendicular to my fingers, I will place my fingers along B, and then I will turn my palm towards A, because B is written first now. B is written first, so I will place it along B and then turn it towards A, and when I'm doing that, my thumb is pointing outward. When I calculate A cross B, my thumb is pointing inward. When I'm calculating B cross A, my thumb is pointing outward. So the directions are opposite. A cross B and B cross A, they are opposite to each other in direction. They would be same in magnitude though. They would be same in magnitude because magnitude is AB sin theta. So that remains same whether we are trying to calculate A cross B or whether we are trying to calculate B cross A. The magnitude remains the same, but the direction of N cap changes. Okay, in A cross B, in this figure, A cross B is inward while B cross A is outward. So we can say that these are negative of each other. Same magnitude, opposite direction means that the vectors are negative of each other. So A cross B and B cross A, they are negative of each other, which also means that vector product is not commutative. Unlike the dot product. Dot product was commutative, but vector product is not. Okay, so that is the first thing that you need to remember. Next, what we can talk about is what happens if I multiply a vector with itself. Well, this would mean A into sine of 0 into N cap, which would be 0, because why sine 0? Because a vector makes 0 degree with itself, so sine 0 is 0. So cross product of a vector with itself, okay, which it will give us 0. In fact, if two vectors are either parallel or anti-parallel to each other, then we will get a 0. Okay. But let's extend it from here. So I cross I, J cross J, and K cross K, they are all 0. They are all 0. Okay. We can also note it down that if theta is 0 or 180, okay, then A cross B would be 0. That means if two vectors are either parallel or anti-parallel to each other, then their cross product would be 0. So we use this to check whether two vectors are parallel or anti-parallel. So we can check that this is test for parallel or anti-parallel vectors. You check their cross product, okay, and if the cross product is 0, then they are either parallel or anti-parallel. Okay. See, there is another way to check parallel thing is that you take the dot product, like we have learnt a general thing, how to find angle between two vectors. Where did we learn that? We learnt it here, angle between two vectors. Where did we learn? I depicted that in this example here. So this will give you the angle between two vectors. So whether it is 0, whether it is 180, whether it is 90, or whether it is anything else, you will get it from here. So so this is the superset. When we are thinking about the angle between two vectors, this is the superset. This gives you everything. Okay. So what I'm trying to say is that we don't really need to know the test of parallel or anti-parallel thingy. We can proceed with the dot product also. Okay. Next point. This is x direction, this is y direction. We know this. Okay, this is I cap, this is j cap, z cap is outwards. Can you tell me what will happen with I cross j? I cross j would be in 1 sine 90 and then n cap. in this diagram, where is n cap pointing? Like, I will use my right hand. I will first place my fingers parallel to the vector written first. I will turn it towards the vector written second. My thumb is pointing outward, which is the direction of k. So n cap is same as k cap. So this is 1, 1, 1 k cap. So I cross j is k cap. All right, I cross j is k cap, which also means that j cross I would be minus k cap, because we know that when we interchange the places in cross product, we get a negative sign. Okay, like the result gets changed by -1. Okay, similarly, let's talk about, let's say this is k direction. What if I talk about j cross k? Notice, so j is in upward direction, k is in outward direction. So j cross k will point in x direction. J is upward, k is outward. This remote is k. Okay, so j dot k, x is toward, so it is I cap, which also means that k dot k cross j is minus I. And similarly, you can check it out yourself. K cross I would be j, and I cross k would be minus j. I'll give you a way to remember this. It's actually a simple way. So to remember this, what you can do, write I, j, k like this, like to form a triangle. And then see, if you are moving clockwise, okay, then you get the remaining number. For example, I cross j is k, j cross k is I, k cross I is j. So if you are moving clockwise, use a positive sign. Okay, like whichever pair you are using to calculate the cross product, the third one will be the answer with a positive sign if you are moving clockwise in this direction. Now, if you are moving anti-clockwise, that means if you are trying to calculate, let's say j cross I, then the result would be minus k. I cross k would be minus j. K cross j would be minus I. So I hope this will help you to remember. Like if you move clockwise, use the positive sign. If you move anti-clockwise, use the negative sign. That should be able to help you to recognize positive and like where we will use the positive value and where you will use the negative value. Okay. Now, if we are done with this, let's go to the next point. Suppose a vector is written as ax I cap plus ay j cap plus az k cap, and b vector is written as bx I cap plus by j cap plus bz k cap, and then we have been asked to calculate a cross b. What should I do? I will write ax I cap plus ay j cap plus az k cap cross bx I cap plus by j cap plus bz k and sin theta. Should I write sin theta? No, students, I hope you remember. I have just substituted the vector. I have not written magnitude of A or magnitude of B, and therefore I will not write sin theta. I have substituted the vector in another version. I have not substituted the magnitude. Now what we have to do, again the same thing, we will expand three brackets, like two brackets of 3 terms each. We will expand, we'll get 9 terms. What are those 9 terms going to be? Let's do it on the next page. So those 9 terms are going to be ax bx I cross I, then ax by I cross j, then ax bz I cross k. And yes guys, I can do this mentally. Yes, I can do this mentally. You will also be able to do it if you start practicing, you know, like you have to keep the term mentally in your mind and you will be able to do it. Ay bx j cross I, okay, then ay by j cross j, then ay bz. It's actually a trend, so anyone can do it. If you recognize the trend, you can do it. Okay, and then az bx k cross I, okay, and then az by k cross j, and then az bz k cross k. Now notice again we have 9 terms. Some of these terms are going to be 0. Can you identify which one will be 0? Can you do that, everyone? Okay, so we learned that I cross I, j cross j, k cross k, these are zeros. Okay, so this is gone, this is gone, this is gone. Unlike the dot product. In dot product, these 3 were the ones which were left and the other 6 became 0. Here, These are the ones that have become 0 and the other 6 are left. Okay, let's continue. Let's continue. Now notice, this is I cross J. So I cross J will be K. Okay, so let me first collect the terms involving K. So this is AX BY. AX BY. I've taken care of this. Let me encircle this. The other term involving K will appear when we have I and J again. Here we have I and J. J cross I, not I cross J. This was I cross J. So we got a K. This is J cross I. We'll get a minus K. So I'll put a minus here and then I will write AY BX. Okay. So I've taken care of this also. So 3 were 0, 2 I have used, 4 are remaining. I cross K, remember I cross K is minus J. We'll check it here. See, I cross K, we are coming in the opposite direction, so minus J. Okay, so this is minus J and this is K cross I, so this would be positive. So plus J and then we have AZ BX minus AX BZ. Did you notice the trend? When you are writing K, you are getting X and Y. When you are writing J, you are getting Z and X. Okay, so we have taken care of this also. We have taken care of this also. Now only 2 terms are left. Okay, this is J cross A, so this is I. So plus I cap and then we have AY BZ minus BY AZ it would be. So this is the outcome, guys. This is the outcome. Okay. Unlike the formula for dot product, which was very easy to remember. The formula for dot product was AX BX plus AY BY plus AZ BZ. This is quite complicated, and the worst part is that if you interchange, you'll get a wrong answer. Like if there would have been a plus sign all throughout, then at least interchanging wouldn't have mattered at all. But right now it does. Alright, so it's quite difficult to remember this. It's quite difficult to remember this. If you want, you can try, but I'll give you another method. I'll give you a trick to remember. We studied determinants so that we don't have to remember this. If you remember how to expand a determinant, then you don't need to remember this lengthy formula. I'll tell you that A cross B, whatever you are supposed to get, you will get it very easily if you make a determinant in which the first row is IJK. The second row would be the components of A, that is AX, AY, AZ. Whichever vector is written first, the second row will form components of that. And then the last row would be the components of the vector written second. So this. And now what you have to do, if you remember how to expand the determinant, just expand it and you will end up getting this. Let me show you. So I will write I cap and then this minus this. So AY BZ minus AZ BY. Let me check the coefficient of I. The coefficient of I, AY BZ minus BY AZ. What are we getting? AY BZ minus BY AZ. Okay, this part we have got. This part we have got. Okay, then next we write minus J and then this minus this. So AX BZ minus AZ BX. Let's check the coefficient of J. Let's check the coefficient. So this is J. Oh, we have a positive sign here. Oh, did I do something wrong? Well, I don't think I did. Here we have AZBX minus AXBZ, AZBX, and here we have AXBZ. So if I pull negative minus sign outside, everything will be okay. You know, watch this carefully. Again, this is same as this. It is not different. It is same. Many times student gets confused because they see a minus here. But you can adjust this minus, send it inside and everything will be okay. And then finally K cap. K cap would be how much? It would be AX BY minus AY BX. Let's check K. AX BY minus AY BX. AX BY minus. So that's it, guys. If you write the vector product in determinant form, then you are all good. No problems with this. Okay, so I hope you understood this also. All right, guys, and let's do an example. Okay, let's do an example. So suppose we have been given a vector A as 2i cap plus 3j cap minus 4k cap and another vector B as 3i cap plus 8j cap minus 7k cap, let's say. And we have been asked to calculate A cross B. Let me show you. So A cross B. Okay, we have been asked. Okay, let me finish the question first. So So what would be the solution? Okay, so A cross B would be I J K, and then 2 3 minus 4, and then 3 8 minus 7. Okay, those of you who are wondering when did I teach determinant, I taught in one of the previous sessions in the same series. Okay, check it out. Okay, so it would be I cap and then 3 into minus 7, that is minus 21, minus 32. Okay, and then minus J, these two, minus 14, minus 12. Okay, and then plus K, 16 minus 9 is equals to, this will become 32 minus 21, 11. Okay, 11 I cap, then 12 minus 14, minus sign is there also, plus 2 J cap, and then this is 7 K cap. So this is the cross product that we are getting. Okay, now applications of cross product. Okay, let me give you one application at least. Okay, so application of cross product would be like torque. There is something called as torque. We calculate it as R cross F. So let's say if there is a point A on which there is a force acting F, okay, then the position, if we want to calculate torque about origin, then the position vector of A with respect to O, all right, R cross F will give us the torque. So again, this is something that will come in the rotation chapter. We'll study about this in great detail at that time. Right now, I'm just giving you at least one name that you can cite as an example if somebody asks you that why have we studied cross product. So you can say that we have studied it so that we can calculate the torque. Okay, we call it as torque. All right, or the other better answer could be I studied it because my sir asked it to study. Okay, all right students, I'll take your leave now. That's all for tonight. That finishes our basic maths course. This is something, if you have mastered this, then you will have no problem understanding any mathematics that you will face in your physics subject. Okay, in the description of this session you will find an assignment on dot product and cross product. You might want to try some questions from that. That will make you familiar with the concept, and you'll be able to use them as and when needed. Bye-bye students. I'll see you in our regular sessions, and I hope you enjoyed this mini course. Do like the session if you did enjoy it. Take care students. Bye-bye.